I think it's 0. But isn't that like a figure? I think it's 0 on top. Because if I have it as 0,
Zero. Next intercept. Extreme solution. Are we okay so far? So our domain is negative infinity to 1, 1 to positive infinity. Our range is negative infinity to 0, 0 to positive infinity. Okay, we all right so far?
Yes.
I looked at the graph.
Oh,
Yes. Yes, if you're not given the equation, you're going to take it off the graph. Okay, and we're going to, I will only give you a nice number. Okay, I'm not going to make you guess 2/3, 1/2. Okay, if you're not given the equation and you're asked for your intercept, you're going to take it off the graph. Best you can. Okay, now, our function. Let's start with our vertical asymptote. What is the vertical asymptote going to give us?
X minus 1. X minus 1.
The denominator here, right? What am I going to have here for my denominator? X minus 1. Okay. Horizontal asymptote is y equals 0. What does that tell you about your degrees?
Degree on the bottom is bigger than the one on the top.
Degree on the bottom's got to be bigger than the degree on the top. Okay.
There's no x intercept. There's just no x.
So say it again. There's none what?
No x.
There's no x on the top. Okay, what do you want to put on top?
Negative 1.
1 or negative 1?
Negative 1.
No, 1.
Oh, but it would be positive. The y
Would it be the opposite?
No,
It would
no
be-
x.
Oh, you're right.
Prove it. Write it on your paper and prove it. We're not going to argue. Write it on your paper and prove it. If you think you should have a negative 1 up here, put negative 1 up here. Put 0 in for y and put 0 in for x and see what you get. If you think it's positive 1, put it in and prove it. If you're going to argue, life lesson. If you're going to argue, check yourself before you start an argument.
I already know what I don't know.
Do what?
Check the y intercept and that means you accept.
Oh, I like that. You should make that up or something. I like that. Check yourself before you wreck yourself. Yeah. Yeah. I mean, come on, we've all done that. We get in an argument, we're so sure we're right, and then we realize, oh my gosh, I'm so wrong and I look like an idiot. So, which is it going to be, positive 1 or negative 1?
I have a separate question.
Hold on. Positive 1 or negative 1? What's it going to be?
Negative 1.
Negative 1? Oh, goodness.
Overall, you can throw the confirmation bias because
Alright.
if you arrived at different answers, you can't want to.
Alright, if I have y equals positive 1 over 0 minus 1, what's my y value going to be? Negative 1. If you said negative 1, if I have a negative 1 up here, what would my y value be? That doesn't work, does it? So, you should have a positive 1 for your numerator. Okay? Yes.
For you're doing horizontal asymptotes, what do you do if the degree on in the numerator is bigger than the degree in the denominator?
If there's no what?
There's no oblique.
There's no horizontal asymptote. It would be an oblique asymptote, which you will learn about next year.
Okay.
We are not going there this year.
Yeah.
Okay? Yeah. So, because somebody wanted to say that means there's no asymptote. No, you can't say that. There is an asymptote. It's just not something we're doing in algebra 2.
So like a
It's
non-algebra
a diagonal
asymptote.
asymptote. Okay, so when you get into that, what's gonna happen?
The non-alpha
Sidetrack over here. What's gonna happen, let's say you have an oblique asymptote, and let's say you have a vertical asymptote. I'm making this up. So your graph is going to look like, like this, and like
That's
this.
pretty cool.
It gets really funky. So we're not going there. Okay.
Yeah.
All right, so we have our function, we're all good to go. All right, next one, now. Ha ha. Ha
You sound so excited.
Aha.
Go ahead and fill in the stuff you know. Hold off on the equation, but fill in the rest of it. All right, so let's see what we got. So it approaches our horizontal asymptote. Our horizontal asymptote is at y equals 0. Our x-intercept is extraneous solution. Our y-intercept is 0, -1. We have two vertical asymptotes at x equals -1, x equals +1. We have no holes. Personally, I'd like to put the range in here. So what would our range be? -infinity to where?
-1.
To -1 with the bracket. Thank you. Right? Because we reach if we're saying that our y-intercept is -1, then that's part of our range, right? And then where do we start after the -1 with the bracket? We go back up to 0 to positive infinity, right?
You said that it wouldn't be square bracket because we don't.
It's not excluded.
If it's an asymptote, it's not a square bracket. This is not an asymptote. This is an actual point on the graph that we do reach. Okay? Good question. Okay, so our domain then is going to be from -infinity to -1
No, you're putting the square bracket on the -1.
because we reach -1 for our range.
Oh, this is range.
This is range. And then we've got -1 to +1, and then we hop over our asymptote again, and we got +1 to positive infinity for our domain. Okay? Now, let's do our function, our equation. Start with your denominator. Who can tell me what our denominator is going to be?
Equal.
Equal? Oh, okay, let me put equal for our denominator. Maybe we want to repeat that. Okay.
Long.
All right, what do I look at to find my denominator?
Horizontal asymptote.
Vertical asymptote, I think.
No.
What do I want to look at for my denominator?
Vertical asymptote.
Vertical asymptote. So what am I going to have in my denominator?
X + 1, x - 1.
All right, x + 1 and x - 1.
Or x squared - 1.
Okay. Oops.
Ooh. Could you just put x squared - 1 or no?
Well, you could put x squared minus
Would
1,
that help with
yes.
the degree thing?
If you knew how to FOIL it correctly, sure, you could put x squared minus 1.
Ooh.
Okay. She said, could you write this as, not with the parentheses, could you write this as x squared minus 1? Absolutely. Yes, if you would prefer to write that, that's fine.
So now we're gonna.
Okay, now,
Wow.
let's talk about our numerator. It's getting a little tricky. Before you panic, are you listening? Before you panic, I will not on the test ask you to find the equation of something funky like this. It will be very basic like numbers 1 and 2 were. But I think for trial purposes, I think we should do the equation for this. Because there's a few things involved, yes. You want to put a +1 at the top? Okay, let's see what happens. If we put +1 at the top, do we end up with a y-intercept at -1?
0 squared is.
Plug in your 0 here, plug in your 0 here. Do we end up with a y-intercept at -1?
The solution. Because 0 plus 1 and 0 minus 1 are all
0 squared is 0, minus 1 is -1, right?
Oh, I was
1 divided by -1 is? Okay, so check, we got our y-intercept, right?
I was adding instead of multiplying.
And this is good. It may be trial and error that gets us where we need to go. Okay, does this function give us, we know we got our vertical asymptote, so I'm going to check that. We know we don't have a hole, let's check that. Does this give us our horizontal asymptote at 0?
Yeah.
Wait,
That was the question.
how do you know that?
Yeah. Yeah.
How do you check for horizontal asymptote?
The degrees of the numerator and the denominator.
Okay.
Because the degree of the denominator is larger than that of the numerator, the horizontal asymptote is 0.
So then yes.
Okay, what's the degree of our numerator? Oh, you're giving me.
It's x to the 0.
Isn't this x to the 0 power? Does it
Okay,
go
wait a
x
minute.
up
Set
here?
that.
So is our denominator a higher degree?
Yeah.
So does this fit our criteria? Yeah. That wasn't so bad.
You could have just said I was right. I was so stressed.
I said 0, and then you were like, are
They
you
need to
sure?
know why.
You said 0, I said, are you sure?
They need to know why.
You were like, okay, let's try
Yeah,
that
I
one.
didn't know it was so bad.
What do you do about the x-intercept difference?
What do you do about what?
The x-intercept difference.
What?
What? There's a.
It would give you, if you put the x-intercept.
That's why we're using it as
zero, and then it equals 0.
But,
That's why
isn't
That's what tells you.
there a horizontal asymptote on the x-axis? If there's a horizontal asymptote on the x-axis, is there possible, let me not say something wrong. In this graph, is it possible that the graph touches the x-axis? No. The only time you're going to get a horizontal asymptote of y equals 0 and an x-intercept is if, let's say, our middle part looks something like this, which we saw that on one of the earlier graphs. That's not what we have here. So if you don't see it, for our purposes here, if you don't see it, that's the, the fine legal, for our purposes here, if you don't see an x-intercept and you have a horizontal asymptote, then you know that this is what you got. Okay?
What if there's a...
You're not liking this. I know you're not. Wait till all I can say, and this is why we used to do all of this as one whole unit in pre-cal, and you found out about bananas and volcanoes and all sorts of stuff.
What?
And then they split it up and they're like, oh, well, let's put some of this in Algebra 2 and let's put the other part in pre-cal. And so it's very hard sometimes because to explain the whole thing, I would have to give you all of the pre-cal topics, which A, we don't have the time for, and B, might just confuse you. So I hate to beg off, but we got to stick with what we got here and work with it.
Wait, so would this be violating that, what you just said? Because I was going to ask.
Go ahead,
If,
ask.
if it does cross, if your graph, the function does cross the x-axis and there's a asymptote of y equals 0, what would the function look like? Would it be the same?
We can do this. Right there. Right there. There is an asymptote at the x-axis, right? If you look at your end behaviors, that tells you that there is definitely an asymptote on the x-axis. However, there is somewhere in here, there is an x-intercept.
Oh, I see. And the degree still is bigger, so you know it's a...
And the degree is still bigger,
I see.
okay? Yeah, the degree is still bigger on the bottom than the top, okay? And for those of you who want the little preview,
No, thank you.
these are bananas.
What are
Okay.
volcanoes?
Volcanoes would be, I don't know if we have a
It was
volcano.
in the problem we were just in.
Yeah.
No, the problem we were just in didn't have a volcano.
It looked like a
Hold
volcano.
on.
Wait, is
Here's a
Isn't that a volcano?
a volcano with an oblique asymptote?
no.
No.
If you ignore this part, This is a volcano.
Oh, I'm see.
Okay?
That's not.
The really brief version is the volcano means that the factor has an even degree, and the bananas says that the factor has an odd degree.
How would that one have an even answer because the
Well, because you have a whole bunch of the factors, not the function, the factors.
Okay.
We don't have to know this, right?
Yeah, okay,
I'm
okay,
confused.
all right, too much TMI, let's go. Let's go back, where are we? Okay, so we got our function here,
Yeah.
right? Whether you write it as factors or you FOIL it together, I don't care, both are fine. All right, back to a simple one. Back to one like you might see. Why don't you go ahead and do that, let's see what you come up with.
Okay.
I did.
Is that it? Is that it?
I don't know. I didn't try to do that. I was waiting for.
Oh wait, I think that's.
All right, anybody think I got an equation that works? What you got, Naomi?
I'm probably gonna wreck myself. But negative 2x over x times, and then parentheses x plus 2.
I like it.
Okay,
I think I wrecked myself.
let's see what happens.
Did you shrink yourself?
Yeah.
What do you think?
It's probably.
What do you think? Jane, what do you
I
think?
think that she got the vertical.
Oh wait, yeah, no, get rid of the negative 2x. Sorry.
Get rid of the negative 2x?
Yeah.
And then replace it with what?
Just
You
just
tell us,
just,
Louis.
just keep x.
I don't know.
Yeah, Louis.
Yeah, wait, that was
Wait.
wrong.
There has to be an X on the top. Is it an X? And then
It's close.
Okay, there has to be an x in the top because there's a 1. Which one are we talking about?
Horizontal doesn't have to be.
Yeah.
Or the degree. No.
So the degrees have to be even. Okay. Can we time out? Can we time out? Where should you always start? Vertical asymptote. Okay, if we have a vertical asymptote at x equals negative 2, what do we have to have in our denominator? All right, so let's start with that. We got x plus 2. Now, I'm curious about this x here. If we have an x here, what does that do to our graph?
Horizontal.
Careful. It's in the denominator.
Vertical.
Well, if I have an x over x, it would make a hole at what x value? 0. Do I have a hole at 0?
I don't think so.
No.
I put it there for.
So I think I'm going to get rid of this x and this x.
Oh.
All right, let's start
Wrecked
there.
myself.
No, that's okay. You wrong. You wrong. Good start.
No,
It better be that. This is
Okay, so
why
you
I
want to keep which x?
I saw the x needed to.
You want to keep the x up on top. Okay, so we have an equal degree and we get a horizontal asymptote at 1. All right, so we got our vertical asymptote, we checked our holes, we checked our horizontal. How about our x and y intercepts? Does this work?
Yeah.
If I put 0 in for y, does x equal 0?
0 over anything equals.
That's true. If I put 0 in for x, I'm going to have 0 over 2. Does that equal 0? Check, check. All good.
I had some stuff.
Eddie's looking at you, honey.
I think this one. This one equals.
Okay. What's that?
Something is with that.
Yeah, we're going to change 5.
This is a volcano.
We're going to change 5. Yeah, 6 is a volcano. We're going to change 5, though, because 5 is kind of dumb if we don't change 5.
Okay.
Are you ready?
I think this
Oh
one.
yeah.
We are going to put 1, 2, 3, 1, 2. We are going to put a hole at 3, 2. Put that on your paper. We are going to have a hole at 3, 2.
Oh no.
All right. So Go ahead and do what you can do. Let's see what you get.
Stop attacking me!
Alright, are there any vertical asymptotes?
I thought you were
No.
It's just a horizontal line.
No asymptotes. Extraneous solutions, there's no asymptotes. That's gonna be our joke for the next month. Extraneous solutions. My x-intercept, we said, was 1, 0. Y-intercept is 0, negative 1.
Wait, since we said extraneous solutions, are we gonna get like the whole question wrong?
No, but you will lose a point.
I definitely know I said that, but you know what I meant.
I passed geometry. I don't assume anything.
Oh, I hated geometry.
Okay, so your domain we've got negative infinity to 3, 3 to positive infinity. The range is going to be negative infinity to 2, 2 to positive infinity, right?
Oh yeah.
As x approaches positive infinity, what does f of x approach? Positive infinity. And as x approaches negative infinity, f of x approaches negative infinity. All right. All right, Eddie.
Yeah,
You think you got it?
We're telling you how to do entire calculus.
What do you think?
Y equals x minus 1 parentheses times x minus 3 over x minus 3.
There's more.
You tell me. Let's check. Hold on. Let's check. We always check for holes first. Is there a hole at x equals 3?
I'm liking this.
Right? If I take this, isn't this a hole at x equals 3? Okay, check the hole. Is there a vertical asymptote? Nothing left in the denominator. Check. No vertical asymptote.
Don't you have to check that the y value for the hole is 2 when you plug it in?
Hold on. We're getting
Older
there.
horses.
Is there a horizontal asymptote in this case? If you were to multiply this together, you'd have x squared over x. Numerator's bigger, no horizontal asymptote.
Oblique.
Check.
It doesn't
Check.
exist in algebra 2.
Okay, now our x-intercept. So if we put 0 over here for y, right? We have 0 equals x minus 1 and x minus 3. Well, this is like solving a quadratic that we've done now for several months. So I'm going to put an equals 0 here, and I would get x equals 1 and x equals 3. But this is our hole, so this is our x-intercept. Oh, look at that. It's beautiful, isn't it? Okay. If we were going to do our y-intercept, I know I'm making a mess up here. If we were going to do our y-intercept, let's see, x would be 0, x would be 0, x would be 0, and negative 1 times negative 3 would be 3, over negative 3 would be negative 1. So, check and check for our intercepts, right? Okay, Naomi made a good point. We got to check the y-coordinate of our hole. Now that I just made a complete mess out of this.
Could you like go back?
Can I go back? Does that work?
Undo.
Yeah.
Does that work? This one?
Yeah. Yeah, it's
Couple more.
like 3 more.
Couple more. Is it doing anything?
Yeah.
It's undoing.
It's even a whole lot.
Oh!
Wait, you can go forward.
That did a whole lot.
Okay. Alright, so for our hole, let's check if I put the 3 in here, and a 3 in here, and a 3 in here, let's see if it works.
Wait, I thought you did plug it into your hole. I think you plugged it into like what's left over.
Well, either way.
Either way, but good point. So, okay, so let's take 3, oh wow. So let's get rid of our hole, and we have x minus 1, so 3 minus 1 is, oh, check. Nice job. Okay? Okay?
Yeah.
And here, if you want to see, there's another volcano. There's another volcano.
Why?
Okay.
We beat up.
I don't like it. This is like my favorite